Hello, today we're going to be looking at lesson 5-7, which is transformations. If you recall, we've already done a transformation this year, but it was dilations. For a dilation, you were changing the size of an object, but not necessarily the shape, or not changing the shape. This lesson, however, we aren't changing the size or the shape. We are only changing the position. So the three main transformations we're going to be taking a look at are translations, rotations, and reflections. In a translation, you're essentially just sliding a figure along a line. It doesn't turn or flip or anything like that. For our purposes, we will be typically just simply going up or down with a translation. So specifically, if we are translating something up, if you think about it logically, it should make sense, but we are going to take the x value and leave it the same. So I'm just going to write this down here. So if we're going up, we're leaving the x value just as it is, and then we're increasing the y value by some number, which will be given to you. The same idea is true if we're going down, but if we're translating down, this time the x will be the same, and the y will be decreased. If we're making a translation to the right, we would change the x. So let's write that down. So our coordinates will change because we'll take the x and increase it by however many units we're moving, but we will leave the y the same. If we're translating to the left, our x will be decreased and our y value will stay the same. On the other hand, if we're rotating, a full rotation 180 degrees around the origin, 0, 0, which is what we'll be doing this year as far as rotations go, would mean that we're turning it all around that center of rotation. So this isn't a full 180 degrees up top here. However, you can see that it has turned around that point. Notice that the blue triangle is the same distance from the center of rotation, which is that dot, as the red triangle is. If it's a full 180 degree rotation, what will happen is both your x and y coordinates will become their opposites. So we would just call this negative x and negative y. And again, it just means they're their opposites. So if it started negative, it will now become positive. And if it started positive, it will now become negative. In the next problem, we're looking at a reflection. Now, a reflection flips the figure. So it's like a mirror image of itself. So if you look at this example, the blue triangle to the red triangle, we are flipping across that axis of reflection. And it's the same distance from either figure to the center or to the axis of reflection. If we're reflecting in the coordinate grid, which is how we will do most of them, we will reflect either over the x-axis or over the y-axis. If we're reflecting over the x-axis, so it's flipping over that axis, the x values will all stay the same, but the y values will become their opposites. So we indicate the opposite with a negative sign, but that would mean if it was originally negative, it'll now be positive. If we're reflecting over the y-axis, this time the x would become its opposite, and the y would stay the same. So this chart that we just created will really be the basis for all of our coordinate movements for each of these transformations. First, all we're going to do is practice actually identifying a transformation that has occurred. So let's take a look at example 1. Pretty clearly we can see that this one was a reflection, and specifically we would say that it reflected across the x-axis. So reflection. We'll say over x-axis. And then in the second one, we can see that the figure started in quadrant 1, completely flipped and turned upside down, and ended up in quadrant 3. So this would be considered a rotation, and it was 180 degrees around the origin, or 0, 0. Okay, next, in example 2, it says draw the image of a triangle with vertices of 2, 1, 5, 6, and 5, 1 after the transformation. So our original triangle is already there, triangle ABC, and we can see it is at 2, 1, 5, 6, and 5, 1. Now, if we are going to rotate a full 180 degrees, what we want to do is make sure we label our new points. Now, just like in dilations, when we label the image or the new figure, it's going to be labeled with the same letter, only now it will have a apostrophe next to it, which is pronounced prime. So we have A prime, B prime, and C prime that we're trying to find here. Now we remember that a 180 degree clockwise rotation is going to take both your X and your Y and make them the opposites. So for A prime, it'll now be -2, -1. And all we mean by opposites is opposite sign. For B prime, -5, -6. C prime will be -5, -1. So now let's plot those and make sure it does appear to have been a rotation. So A prime was -2, -1. B prime was -5, -6. And C prime is -5, -1. So now we'll connect those. And we see that the figure does appear to be the same, but it is certainly has rotated. Okay, next, let's take a look at example 3 here. And it starts by saying, draw the image of a parallelogram with the given vertices. So let's start with that. So we have first, let's call them A, B, C, and D. So we have A, B, C, D. And let's begin by plotting those. So A is at 4, 5. B is at -3, 5. C is at -5, 1. And D is at 2, 1. So make sure they're all labeled. And then we'll connect them. And this certainly appears to be a parallelogram. Now, because this figure is translating down 4 units, what that would mean to the new coordinates, I'm just going to move this over a tab, what that would mean for the new coordinates, so for A prime, we'll just go ahead and write it up here, is our X will stay the same, but the Y will be decreased by 4. So that means A prime, which was originally 4, 5, would now be 4, 1. B prime, which was originally -3, 5, will now be -3, 1. C prime, which was -5, 1, would now be -5, -3, and D prime, which was 2, 1, will now be 2, -3, because we subtracted 4 from each of the Y coordinates. So now we'll plot them on here. So A prime, which is 4, 1, would be right here, and it's okay if there's a little bit of overlap. B prime is -3, 1, so that's going to be right here. C prime is -5, -3, and D prime is 2, -3. And so now we'll connect them. And we can see that it's the same figure but has been translated down 4 units. Okay, next we're taking the exact same figure, so I'm going to plot the original points again. So A is 4, 5. B is -3, 5. C is -5, 1. And D is 2, 1. We're going to connect them. And then we're going to reflect over the x-axis. So remember what's going to happen if we're going to reflect over the x-axis. The x-coordinate will stay the same, but the y-coordinate will become its opposite. So let's start with A prime. So A was originally 4, 5, so now it will be 4, negative 5. B prime was originally negative 3, 5, so it will be negative 3, negative 5. C prime was negative 5, 1, so it'll be negative 5, negative 1, so only the y is becoming its opposite. And D prime was 2, 1, so it'll now be 2, negative 1. Okay, so A prime, 4, negative 5. So we're going to start at 4, go down to 5. Negative 5 that is, and that's going to be our A prime. B prime is negative 3, negative 5. C prime is negative 5, negative 1. And D prime is 2, negative 1. So now we connect them. And we see that it does appear to be a mirror image of the original. And that's transformations.